Hello folks! In this video we're going to finish off our application of our knowledge of derivations and iterators inside of Power BI so that we can move on to some of the more fun stuff. So without further ado, let's go ahead and get started. I'm here in Derive Iterate application.pbix. This is a Power BI file, not an Excel file, right? And I'm here in the third tab, all PT, and we're actually going to do this tab and this tab in the videos. We're going to do something that you probably won't do very often. We're going to use these non-respectful derivations inside our aggregation iterators. For the most part, you're actually going to take these non-respectful derivations and stick them into filter to create new filters to stick in the filter context. But since we don't know that much about actually revising the filters yet, we can't quite do that. But there's no rule that says you can't take these non-respectful derivations and use them in these aggregation iterators. So we're going to go ahead and do that just so you can see that it does indeed work, and it works about like you'd expect. Okay, so again, we're here in the All PT tab. I'm going to twirl open my measures table, and I'm going to twirl open C All PT, right? So we're going to use this, this derivation right here where we point the all function at an entire table, which will bring back all the rows and columns of that table, regardless of whether or not they are visible. It is going to ignore the filters. So let's click here where it says units all, right? Right now the measure just returns a blank, which is why we've got a bunch of blanks there. We can see here in the comment block, which goes from there to there, that's what it is, it's comment block, what our finished code is going to be. Speaking of which, let's go ahead and type it out. So I'm going to head to the end of line 2, hit backspace a couple times. We're going to do sum x, right? And I'm going to add my own opening parentheses and do shift iterator. And we're going to build a builder pattern, right? A builder pattern is anytime you have a table derivation inside of an iterator. There's our iterator, sum x. What's our table derivation? We're going to do all, type in ALL, add opening parentheses, right? And we're not going to point it at a column. We're going to point it at the entire table. So just go ahead and double click on mini right there to have it finish typing it out for us. If you want to type it out yourself, you are free to. I'm going to add closing parentheses and a comma. If you want to have spaces before and after the mini like you have down here, you can go ahead and do that. It actually won't really affect your code that much. So if you want to, go ahead. If not, don't worry about it. Okay, so I'm here on the end of line 3. I'm going to do shift enter. That's our table derivation. That is the temp table we're going to add an expression column to. What is the definition of our expression column? Well, what we want is just all the units, regardless of the filters, right? So how are we going to get that? I'm going to go ahead and type in mini, and I'm going to find units right there, and I can either arrow down and hit tab or double click on it or type it out. I'm just going to double click on it. Okay. So for every single row, get that row's units, and then when we're done, sum up the results. So go ahead and do shift enter, hit backspace to line up the cursor with the sum, with the S in sum x, and add closing parentheses. Now go ahead and hit enter. And when we do, we get 12, 12, 12, and 12. So why do we get the same answer for every single cell? Well, that's because we use this derivation right here, all pointed at a table, that completely ignores the filter context. So for this cell, the filter context is indeed shift equals lunch. Just like for this cell, the filter context is shift equals dinner. But this derivation completely ignores the filter context. So when we say go get all the rows and columns of mini ignoring the filters, sure enough, we get all the rows and columns of mini ignoring the filters. It ignores this filter for shift equals lunch. So we get the same temp table in this cell as we do in this cell, as we do in this cell, as we do in this cell. It's always the exact same temp table. All the rows and columns of mini, okay? So where do we get the number 12? Well, that's simple arithmetic. For every single row, we get that row's units, and we sum it up because this is the sum x function. So we get 2, so we get 2 right there, 1 right there, 1 right there, 3, 2, 1, and 2. And if you want to get a calculator out, if you add all those up, if you add all those numbers up, what do you get? You get 12. You get it if you add all those up, all those up, all those up, and all those up, because it's always the same result, the expression column, because we get the same temp table for every single cell. Okay, so not super interesting, but you know, it's good to know that you can do it, right? Again, usually you'll pair this all derivation, these non-respectful derivations, with the filter function, but you could certainly use them in an aggregation iterator like sum x. So let's pop over to the next tab. We'll just do these all at once. Okay, very similar idea. We want the distinct dishes, but this time we want to ignore the filters. Why? I don't know why. Mainly so that I can show you that it actually works. And that's about it, okay? So here, again, we've got two summary tables, same as before. This one we're breaking down our measure, distinct dishes all by shift. Here we're breaking down distinct dishes all by type, right? So for this cell, we've got a filter context of shift equals lunch. For this cell, we've got a filter context of shift equals dinner, and I think you can see where I'm going with that, right? So let's go ahead and type this measure out. So I'm going to head over here to my measures table, twirl open D, and click on this distinct dishes. This is distinct dishes all, right? And here in the comment, we've got what our finished version is going to look like. So let's go ahead and type it out. Let's click on the end of line 2, hit backspace a couple times until we get to the beginning of the line. And go ahead and type in sum x. That's the iterator that we're going to use. Go ahead, add opening parentheses. Do shift enter to go to the next line, right? And what's our derivation going to be? Well, this time we're going to point the all function, not an entire table, but just a single column, specifically the dish column, to get all of the values of that column regardless of the filters. Okay, so go ahead and type in ALL, right? Go ahead and double click on all, right? Add a space. You don't have to, but I'm going to add a space. And which column do we want to point at? Well, I can see what it is right there. I'm going to start typing in mini just to narrow down my list. And I want the dish column in the mini table. So go ahead and double click on dish mini right there. Okay. Add a space and a closing parentheses. That is our derivation. That will produce a temp table that we're going to add an expression column to and sum up. Go ahead and add a comma and do shift enter. Okay, so speaking of which, what is the definition of our expression column? Well, we just want to know how many distinct dishes there are. So basically, we want a row count. So what do we want? We want a 1, a 1, and a 1. So what's our definition of our expression column? Just the number 1. That's it. Go ahead, do shift enter, backspace, and closing parentheses. If ever you want a row count, use the sum x function, and for your expression, just use the number 1, the expression column, the number 1. That's it. So we're going to go ahead, hit enter, and instead of a bunch of blanks, we're going to get 3, 3, and 3. What's the reasoning for that? How come it's the same number even though this is supposed to be lunch, this is supposed to be dinner, this is supposed to be go, and this is supposed to be dine in? Well, that's because we've used this derivation right here, which is the all function pointed at a column, which ignores the current filter context. So that derivation ignores this filter, it ignores this filter, it ignores this filter, and it ignores this filter. It ignores all the filters. And so for every single cell, it gets the same temp table, which is all of the distinct dishes in the data model, regardless of the filters. So we get pasta, burger, and salad. We then add a column to it with just the definition of 1. So we get 1, 1, and 1. And we sum it up because this is the sum x function. So 1 plus 1 plus 1 equals 3. And we get the same thing for every single one of these cells. 1, 1, 1 equals 3. 1, 1, 1 equals 3. 1, 1, 1 equals 3. Okay, and so that is a basic tour of all the different stuff we could do using the very simple derive and iterate builder pattern that we've learned so far. Right? In the next videos, we're going to start learning how to actually revise the filters, which will allow us to do really complicated, fun stuff inside of DAX. It's really where DAX kind of opens up and becomes a very sort of dynamic and powerful language. So, hope to see you in the next videos.